Ми працюємо за принципом асоціації і об'єднуємо данські компанії, які спеціалізуються на централізованому теплопостачанні. Це як і виробники обладнання, так і виробники тепла та ті, хто його постачають, а також консалтингові та інженірингові компанії в Данії. І наша діяльність зосереджена на розвитку сектору, як в Данії, так і на міжнародних ринках, де ми підтримуємо проекти модернізації. Україна також входить, звичайно, в ці ринки. Ми реалізуємо партнерські проекти, вони спрямовані на, перш за все, трансфер знань, на стратегічне планування, звичайно ж, демонстрацію найкращих практик у сфері енергоефективності і використання відновлювальних джерел енергії та на модернізацію. І сьогодні я модеруватиму наш вебінар. Дуже дякую всім, хто доєднався. Багато знайомих облич та імен, це дуже приємно. Судячи з кількості зареєстрованих, наразі в нас 209 учасників. Тема нашого вебінару дуже актуальна, і ми будемо говорити про інвестиційні рішення в централізованому теплопостачанні, а саме чому важливо оцінювати не лише вартість придбання, а повну вартість володіння системою протягом усього її життєвого циклу. І сьогодні в нас є данські спікери, які знаються дуже добре на цій темі. Ну і взагалі, можливо, вам відомо, що Данія є таким провідним гравцем на цьому ринку і всіх технологіях у світі. Ми організовуємо цей вебінар у співпраці з проєктом «Угода мерів Схід». Сьогодні до нас доєдналися представники Теплокомуненерго, ми запросили також представників муніципалітетів, територіальних громад, тож ми дуже раді бачити таку широку аудиторію. Зараз хочу зазначити декілька організаційних моментів для того, щоб все пройшло у нас сьогодні вдало. В нас працює синхронний переклад. Ви можете обрати потрібну мову в меню перекладу внизу вашого Zoom-екрану. Так? Сподіваюся, у всіх всі знайшли.
Звук знайшли, ну нахилі.
Так. Угу. Також, так, будь ласка, тримайте мікрофони виключеними протягом вебінару, щоб не заважати спікерам, які виступають. Це відволікає. Дякую дуже за це. Якщо ви хочете поставити питання, в нас буде блок питань та відповідей після всіх презентацій. Пишіть або, будь ласка, в чат, або піднімайте руку. Ви знаєте, така функція в Zoom є. І, звичайно, ми надамо вам слово. Я і мої колеги з угоді мерів. Презентації всіх спікерів вже завантажені на лінк. Я також його скину, це посилання в чат, і ви зможете завантажити під час заходу або пізніше, коли вам буде зручно. Тож сьогодні з нами, як я вже зазначила, провідні данські експерти. Ми поговоримо про стратегічні закупівлі з урахуванням експлуатаційних витрат. Також будуть презентації на тему рішень в галузі біомаси, насосів, тепломереж. І до нас доєднався данський фонд АЙФО, який розкаже про можливості довгострокового фінансування для українських теплокомуненерго. Отже, ще раз дякую за вашу участь, бажаю всім продуктивного вебінару. І зараз з задоволенням передаю слово пані Оксані Кисиль, яка є національним експертом проєкту «Угода мерів Схід». Пані Оксана, будь ласка, забирайте мікрофон.
Так, колеги, доброго ранку всім. Вітаємо з Києва. Якось ми довго думали, як об'єднати всі громади довкола теми збереження централізованого теплопостачання, тому що ми розуміємо, яке навантаження зараз ви як громади маєте, як комунальні підприємства, багато що пов'язано з тарифною політикою, яку ви не можете або не можете змінити в чинних умовах, багато пов'язано із зношенням, із викликами війни, і якщо так підсумувати, то у вас більше проблем зараз з громад пов'язані з централізованим теплопостачанням. Деякі громади починають вирішувати це шляхом індивідуального опалення на рівні багатоквартирних будинків. Але мені здається, тут зібралися ті стійкі громади, які будуть виборювати існування систем централізованого теплопостачання в Україні, тому що це одна із найдійніших систем, яка може надавати якісні послуги при умові її трансформації і інвестування. Чому це одна із надійніших систем? Тому що коли будинок переходить на індивідуальне там опалення, це загалом газові котли, від'єднується від централізованого теплопостачання, то в цьому будинку іншої альтернативи, ніж газ, немає. Або знову повернення до централізованого теплопостачання через ще більші інвестиції. Те, що ми є залежними від газу, це одне питання, але коли є система централізованого теплопостачання, ви можете диверсифікувати ризики і використовувати різні види локальних видів палива і в той же час газ. Тому для нас важливо зрозуміти данський досвід, як вони зберегли і більше того розвивають системи теплопостачання. Для вас важливо також зрозуміти той фінансовий механізм, який буде презентований наприкінці. Для нас, як проєкту, важливо, що ви можете по результатам вебінару окремо звернутися до угоди мерів, якщо у вас є проєктна ідея, як розвивати систему теплопостачання, то ми можемо окремо проговорювати ваші проекти і співпрацювати в рамках Project Pipeline. І ще одна як пропозиція, якщо під час сьогоднішнього семінару ви не знайдете відповіді на ті теми, які хвилюють вас, і торкаються централізованого теплопостачання, ми радо приймемо пропозицію про продовження циклу вебінарів, саме пов'язаних із системами теплопостачання. Будь ласка, пишіть в чат пропозиції, що ми ще маємо дорозглянути в наступних циклах вебінару або в офлайн завтра. Успішного вам вебінару і по-доброму візьміть максимально все з датських колег саме в питання знань і практики. Дякую вам.
Дякую дуже, пані Оксана. В нас хтось поширив екран? Так? Я б хотіла передати слово пану Ларсу Улєву з наступною презентацією. Ларс, чи ви могли би зараз почати презентацію вашу? Ларс Гулів – це провідний експерт в секторі централізованого теплопостачання, відомий в цій області знань в інших країнах, тому ми залюбки почуємо презентацію вашу, Ларс. Дякую.
Okay. I will do my best here. Tuk, 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 tuk.
Ми бачимо.
Okay.
Все видно, дякую.
Yeah, good. Thank you very much for the invitation to this webinar and giving me the possibility to put focus on what's important when you are in a situation to make new investments. I'll try to give you a picture of how we, at least in Denmark, in the company where I have been before, the Vex District Heating Company, responsible for the district heating supply to the western part of Copenhagen, how we do it when we make a decision to make investments in larger components like pumps, like pre-insulated pipes, like boiler installations. So use your district heating money efficient. That's the title of this presentation, with focus on life cycle cost instead of just having focus on the upfront investments. When you buy a car, of course, you need some money give to the car dealer for buying the car. So you have a capex, a capital expenditures. That means the investment you have in the car here now, and this investment you have to depreciate over a period of some years, 6, 7, 8, 10 years. You have to take into account the interest rate. And with these figures, the investments, the depreciation period, and the rate of interest, you can calculate how many euros per year you have to take into your budget for financing this car you have bought. But I hope that you also look at the cost for having the car, the operation cost, the OPEX, the operation expenditures. This cost, they are split up in a fixed part and a variable part. And the fixed part, that's for instance insurance for the car. It could be a green tax, which we have here in Denmark, which we have to pay to the state every year, independent on how much we use the car. You can have cost for parking the car, etc. And then you have some variable cost depending on how many kilometers you are driving per year. You have maintenance and service of the car. You have the tires, which you have to exchange after 30, 40, 50,000 kilometers. You have normal service for changing oil, etc. And then a huge cost is the cost for gasoline, for petrol or for diesel. And there could be also other variable costs. So when you make your budget, you have to take into account the capex you have, fixed cost every year, the operation costs, the fixed part, and the operation cost, the variable part. If you do just look at the investments and you have money for that, but not for the OPEX, for the operation cost, you will never be able to drive in your car. It's the same with district heating and district heating components. When we talk about price, it's split up in different elements. You have the upfront investments, you have the maintenance over lifetime, you have the power consumption or the energy you need to buy to put into your boiler over lifetime. And if we talk about a pipe system, you have the heat losses over lifetime. So when we talk about price, it's the total cost over the lifetime for the components. It's not enough that you only focus on the here and now investments, or as we call it, the upfront investment. So to start with, I will put focus on what we have done in our company when we are buying larger pumps and pre-insulated pipes. And at the end of the presentation, I will put focus on what you also have to put focus on when you are going to buy boilers for instance, biomass. If we start with the pumps, then it's very important that you focus on the necessity for the pump system to last for many years. And for this many years, it's necessary that you can have a reliable operation of the pumps. And therefore, it's essential that you are very critical when you design the pump correct from the start. If you have a poorly designed pump system, then it will generate decades of high maintenance and poor reliability for the operators of the pump. But the most important is probably that if you have designed a pump wrong and placed it in your system, the only way to fix that problem, that is to redesign the pump and the system. And that's a very expensive decision to make. when we look at how to design a pump correct, it's necessary that you go into details and try to estimate how the pump will be operated in your district heating system. The situation could be that the heat demand will increase over the years, that you have to take that into account when you design your pump, so it's designed for a larger flow in the coming years. It's also important that you put focus on the situation if you are installing a pump which you could operate both summer and winter, or if you install specific pumps for winter production of district heating and summer production of district heating. I've tried to set in to the right at the slide that you have different demands for heat, and you can see that the amount of operation hours per year could be very different from one situation to another situation. And that together with the efficiency of the pump, where the efficiency in the different working points are different, results or mean that it's important that you design your pump correct, taking into account how many hours per year it will be operating in specific working points. If you don't make that calculation, it's more or less gambling if you will have a success with the pump or not. When you have bought the pump and you have put it into operation, the cost for having the pump is shown on this slide. It's just an example, and I have put in the source so you can find the figure at the internet. But this is a picture of the total pumping costs, which can be estimated to this $600 per kilowatt per hour of power, of which up to 70% is electricity consumption. You can see the smaller pumps there, the percentage share of the cost related to the electricity consumption is smaller, but the total costs are larger. And if we have a pump of this 5,000 kilowatt or 5 megawatt, the primary cost for operating the pump, that's electricity cost, and the electricity cost, they cover totally 85% of the annual cost. So here it's evident that if you haven't designed your pump correct, you will lose a lot of money because 85% of the total cost, they are related to the operation of the pump. There's a difference from around 50% for the smaller pumps and up to 85% for the larger pumps. But that just to ensure that you have that in your head when you are looking at the cost for having a pump. When we call for tender for larger pumps, of course, we give to the supplier of the pumps information of the head we need for the pump, the amount of meter water column it could operate with, and the flow. But we also focus on the efficiency of the pump. We put into the tender specific working points where we ask about the efficiency for the pump working in this operation point. We also take into the tender that the efficiency of the pump in this specific operation points, it has to be confirmed during the operation. That means after the pump has been in operation for some months, we are measuring the efficiency in these specific working points. And if this criteria from the tender is not fulfilled, there will be a penalty for the supply of the heat of the pump. Another picture here shows the life cycle cost for a pump. And again, you can see here it's split up in the specific elements where the total investment in the pump, it's only around 10% of the total life cycle cost. And here the energy consumption is 45%. So this picture shows that it can be very expensive for you if you save a little bit of money when you buy the pump, if the consequence is that the electricity consumption during the lifetime of the pump is much larger. So it can be very expensive to try to save money when you make the primary investment in the pump. When I talked about this efficiency curves and efficiency of the pumps, it's necessary when you get your tenders that you compare the different products, the different producers of the pumps, because the efficiency in specific operation points defined by you can differ from one producer to another producer. This is just an example where you can see that from pump A, the efficiency with only 20 cubic meters per hour is 20%, and that's better than the 15% from pump B. But when we look at the operation point with 70 cubic meters per hour, the efficiency from pump A is only 65%, and from pump B, 70%. And the same situation we have with the flow of 90 cubic meters per hour, their efficiency is 48% or 45%. So out of this table, you can't decide which pump is the best. That depends on how the curve for your flow in the system will look. Maybe here the pump A is the best, maybe it's pump B. I can't tell you here because it depends on your actual operation situation and your system. But you have to look at these figures from the different potential deliverers of the pump to your system. Focus also on what we call the BEP, the best efficiency point. That's the point where you have the lowest energy consumption in the pump or the best efficiency. And you have also to compare that from the different offers you get from the different producers. So when I focus on this life cycle cost, LCC, it's in fact a concept which refers to the total cost of a product or service over its lifetime. So when you look at that, you can be sure that you take into account both the upfront investments, the operation cost, the maintenance and repair cost, how to get rid of the product again, and then you can compare products from different producers in an you can see in a fair way, because it gives a picture where you can compare one product to another product. Furthermore, this life cycle cost analysis can help you to minimize your total cost and by that maximize your energy efficiency for many types of systems, including pumping systems, district heating pipe systems, and boilers. So it's more or less the same method you use when you compare different cash flows from different projects where you use the net present value way to calculate which product is most favorable. So my recommendation for the content of your tender documents is, of course, you ask for the price of the pump. If possible, you could also ask for the price of a maintenance agreement if you are interested in such one, and if it's offered by the suppliers of the pump. Then you ask for the pump efficiency at specific operation points, and you inform that it's necessary that this efficiency at specific operation points, they are demonstrated and verified after the commissioning of the pump. And then you try to calculate how you should be compensated if the required efficiency of the pump cannot be demonstrated or cannot be verified. So the correct design and high efficiency at the pump at the normal operation points, they are much more important than the here and now investment in the pump. Then we jump to the pre-insulated pipes. I don't know if it's easier to make the same calculations here because there are more parameters you have to take into account. You can buy the pre-insulated pipes in different series, series A, 2, or 3, and the series number reflects to the thickness of the insulation. That means that a series 2 pipe is better insulated than a series 1, and 3 is better than 2. I have just put a red circle around some of the figures, so you can see for this dimension of 300 millimeters, a series 1, there the heat losses, they are around 41 watt per meter, series 2, 3 watt per meter, and series 3, 27 watt per meter. So a decreasing heat losses if you go from series 1 to 2 or to 3. So you will save money here in your operation phase by having lower heat losses, but at the same time you increase your investment here now because it's more expensive to buy series 2 compared to series 1 and series 3 compared to series 2. So here it's again you can reduce your operation costs by increasing your capital costs. And what to do, that depends on different figures I'll come back to. You also have to decide if you will buy this pre-insulated pipe. Now this is just an example for series 1, but you can buy it as a single pipe or a twin pipe. A single pipe, there you have one pipe for flow and one for return. In a twin pipe you have flow and return pipe in the same outer casing. Here again you can see that if you choose the conventional way to having two separate pipes, the heat losses for an 125 diameter pipe is 28 watt per meter, and it's almost the half if you choose a twin pipe. So here again you can reduce your operation cost by investing more money in the when you're buying the pipes. Here again, what to do depends on what's the cost for the heat you send through your pipe system over the lifetime for the pipes. Duke. So the elements you have to take into account when you design your pipe system for minimizing the life cycle cost, it's if you want to choose a single pipe system or a double pipe system. And then you have to decide which series do you want. Is it 1, 2, or 3? Then, when you have made this decision, or before you make the decision, you also have to take into account that it could be more expensive to construct the pipe system with 2 single pipes compared to a double pipe, because you have to make a wider ditch for the pipes. Then you have the maintenance cost over the lifetime. You have to look at the maintenance cost for the single pipes or double pipes. If it's a single pipes, you have the double amount of joints, which where it could be necessary to maintenance a part of them in the lifetime of the pipe system. You have fewer joints when you are operating with a double pipe system or twin pipe system. And then you have the heat losses, as I just described. They are different from single pipes and double pipes, and they are different depending on which series you have bought. And very important element when we look at the operation costs for having this pipe system, that's the price for electricity and the price for the heat you will send through the pipe system. So you have to estimate how the price for the heat you buy and put into the system, how that will develop over the next 20 years, for instance. It's not easy, but there are some help you can get. The elements to take into account for minimizing the life cycle cost, as mentioned, which insulation series should you choose? Should it be single or twin pipes? There are a lot of parameters here, so where can you find help? There are some free tools at the internet from the producers of the pre-insulated pipes where you can get help. There's one from the company Logstor, and you can just Google Logstor calculator. There you will find these free tools where you can put in your specific parameters for heat price, electricity price, and then you can see what's the consequences if you choose single pipe or double pipe, if you choose insulation series 8 or 2 or 3. And the same if you go to the ISOPlus website. There you can Google ISOCalc, and there you also have a free software tool you can use, the total cost of ownership. So it sounds complicated with these pipes, but there's good help you can get access to free at the internet. When we then jump to a boiler, then the boiler tender document should include, at least if I was responsible for it, of course, the capacity of the boiler in megawatt, and also asking for which kinds of biomass can be used in this boiler, or which kind of biomass you want to use in the boiler, and also ask for the moisture contents in the fuel, to ask that question to the supplier of the boiler. When I mention this type of biomass, the background is that it's probably necessary for you to have a flexibility between different types of biomass. The situation on the biomass market, it can change over the next 20 years, meaning that here now you will maybe use wood chips or straw, or maybe you will use products from sunflowers. but in the next 5 or 10 or 15 years, it could be other sorts of biomass which you wanted to use, and it is necessary that the boiler you have bought also can use and can operate with these kinds of fuels. Then it's necessary to put focus on the efficiency, and again, this efficiency in predefined operation points with specific types of biomass and moisture contents, it must be demonstrated and verified after the boiler has been sent into operation. And again, try to include in your tender documents a compensation which you should achieve if the boiler doesn't achieve the efficiency. It's important because a lower efficiency than expected, that would hit you over the total operation period for the boiler. That means the next 20 or 25 years. So here again, the operation costs, they are very important compared to the investment in the boiler here now. To summarize, when buying a pump, the investments in the pump, it can be 5 to 10% of the total life cycle cost. The operation cost can be up to 85% of the total life cycle cost. That means that the efficiency in the specific operation points for the pump, it's essential for the total economy in your district heating system. Therefore, it's relevant that you have a high focus on correct design and efficiency of the pump at relevant operation points, and it's much more relevant than just putting focus on upfront investments in the pump. And then again, the demonstration of the efficiency at the operation points after the commissioning, and a compensation if this efficiency cannot be demonstrated. For the pump, for the pipes, it's essential for a long lifetime that you choose the right product from the beginning. That means that you have focus on the heat losses in the system. You have focus on the cost for the heat you put into the system or the lifetime of the system. And it's essential for the lowest life cycle cost that the balance between investments in pipe system and installations and heat losses of the systems over lifetime. So for the biomass boiler, flexibility in terms of choice of fuel, because the market cannot be predicted for the next 20 to 25 years, and optimal efficiency in the most common operation points, and then robustness in boiler efficiency in terms of change in the moisture contents of the biomass used. So that was a very quick introduction to life cycle costs. So thank you very much.
Дякую. Дуже цікава була презентація. І наразі я думаю, що тема настільки об'ємна, що і декілька днів не вистачить для того, щоб її розкрити повною мірою. Я наразі хотіла би передати слово наступному спікеру Єспер Стрела, менеджер з експорту компанії Linka Energy. І він розповість про інвестиції в котли на біомасі. Дякую, Єспер. Так, якщо є питання, будь ласка, пишіть в чат. Ми обов'язково промодеруємо відповіді на них в кінці.
Oh, I'm here. Just need to unmute. Thank you for having me here. I'm very pleased to see so many, but it just shows the need for and the interest for all this that we have to supply. I'm gonna tell a little about biomass boilers. Lars made a good presentation about some of the important things to ask for in the tender materials, and he's completely right in what he's saying. We have made biomass boilers for the last almost 50 years, and we know how to do it. We are very good at burning straw, which is quite difficult, and some of the fuel that you have a lot of in Ukraine. So I think that's why we have such big focus on the country right now. Our boilers, our quality, and everything else. And as Lars mentioned, it's important to look into these things. You can easily buy a cheap boiler, but then it probably lasts 5 to 8 years if you burn straw. So it's important to look at the quality when you buy things like this, that you buy something that can last the 20 years or more. Otherwise, it can be a very expensive decision to do. Biomass is a lot of things. When I talk about biomass and when I talk to people around the world about biomass, then they always think that it's only wood chips, and that's not the case. We can burn all kinds of biomass, and I'll come back to that later. But biomass in essential is a matter of taking something that contains CO2 and get something out of the CO2. So if you leave wood chip in the forest, then it will lead out the CO2 that it gathered when it grew. So why not harvest the CO2 to do something? You can actually also collect the CO2 afterwards, but it makes sense to use the CO2 that's there already. If you use gas, for example, then you take up something that's in the ground, the CO2 is in the gas in the ground, and you take it up and you burn it and you lead out CO2. That's not very green. Biomass is using CO2 that's already there and will be let out into the atmosphere if you don't either pick it up by burning it or using it in biogas, for example. Again, compared to some of the other things there are on the market when it comes to biomass, it's an easy way to pick a good heat source. There is biomass all around us. It's just a matter of finding the right one. But when you use biomass, the benefit is that you have energy no matter how the weather is. If you use wind or solar, which is a very good solution, then you are depending on the weather. And I know that the weather can change in Ukraine as well as it can in the rest of the world, especially here in Denmark. We have a lot of windmills and a lot of solar panels, but we also have a lot of days where it's completely gray and cloudy and no wind, and then we don't have any energy. So it's a good idea to mix the things. It doesn't have to be one thing. It doesn't have to be only biomass. It can be biomass and wind, biomass or solar panels. It actually works completely good together. Biomass also works very good together with a heat pump. So there are many things where you can put a good solution together without only choosing one. So again, back to what's biomass. Biomass can be a lot of things. Again, usually it's wood chips, but it can be straw, it can be cherry stones, olive stones. You have a lot of sunflower husk in Ukraine. In Japan, we burn rice husk. So it's the most important thing is to look what's nearby. You're not supposed to transport it a long way. It should be something that's in the near surroundings. We can make boilers where we can mix the fuels, so you can use 2 types of fuel at once. But we can also, where you can use one. If you decide to build a boiler on wood chip and you 5 years later figure out that now I want to burn straw, it's quite easy to redo the boiler so it can burn something else if you didn't do it from the start. Of course, if the more fuels you mix, the higher the price will be, of course, because there are things you have to put into the boiler system. But it's easy to change in most cases to another fuel. here's just this example on the efficiency on different kinds of things. You would be surprised how many things we try to burn. We have a test facility in Denmark here in Linka. So if you have anything from waste from some industry with agriculture or something like that, we can test it. We can see how efficient it is, how the emission is, and so on. But it's surprisingly how many types of biomass that you can burn. There is this thing about efficiency when it comes to biomass boilers. A lot of people think that they are not as efficient as gas and heat pumps and so on, but it depends on the moisture in the fuel and of course what type of fuel and pressure and so on. But you can actually get a biomass boilers to go up to 110% if you use the right system. So there are no excuses to use when it comes to efficiency, because it's at least as efficient as the other things. I just made a comparison here on how the average number is on the things. There are things that are, if you look at your country at this moment, gas boilers is a cheap solution to buy, and it's cheap to use right now because you have some limitation on the prices on gas, but you probably won't have in a year or two. Then they will probably go to market prices, and then it can be a very expensive thing to have gas boilers. We have seen that in Europe the last couple of years. When it comes to electricity, electric heating is absolutely green if the electricity comes from a green place. But again, the electricity prices can vary a lot. But it also requires that the grid is ready for a heat pump, for example. It requires a lot, and it can be very expensive to build that part also. When it comes to the future, we also have to look into how easy is things to operate, how many employees should there be, and so on. It doesn't require a lot to have a biomass boiler. I know there are regulations in Ukraine that requires there's always a person present at a boiler system, but here in Denmark, for example, most of the places we have with district heating, the biomass boiler can run for 72 hours without people present. Everything is controlled by the phone or iPad, and it's completely easy to operate and with very low downtime. So there is a lot of good reasons why to invest in biomass. So one thing is, of course, all the environmental things, the carbon footprint and so on. We have seen during the last energy crisis we had here in Europe that the prices on biomass were more steady than all the other things like gas and electricity. The district heating companies who had biomass boilers here in Denmark were very happy to have a biomass boiler and not gas or electricity, because they had a very low cost on heat compared to the others. One of the other things there is that you keep the economy in the local area. So when you pick up straw from the field or wood chip from the forest and so on, it's local workforce who does it, and the money stays in the local area, which is a good thing for most places to have things like that. It creates jobs, and yeah, it's a very good way to keep the money in the local area. Again, it's also easier to get people to live nearby a green district heating central than, for example, a coal or gas boiler. Again, it's a matter of looking at what's nearby, and I'm frequently in Ukraine, and I would love to come by if you have any requests. and tell you more about how it is, and look at your local area and see what kind of solution we can make for you. It's a tailor-made solution for every part. We don't have a fixed solution, and not many of the boiler suppliers have that, because you have to look at the individual case and the biomass that's nearby, and the need and the pressure and the temperature and everything else. There's a lot to take in consideration. So the best thing is to have an on-site meeting, and I'm ready to come and see if you need anything. I have my contact information here, and I'm sure Lesja will share the slides afterwards. But that was my presentation. Thank you.
Дякую, Єспер. Thank you. Я в чат скинула лінк на презентацію. Ви можете скачати презентації вже. Сподіваюсь, він буде не перевантажений. І даю слово нашому наступному спікеру. Нікlas Lindblom представляє компанію DESME, і ми поговоримо про насоси. Нікlas.
Hello, and thank you to participate in this event. And thank you to Lars also earlier, who touched the subject with the pumps, and I will deeply down a little bit in it more. So now you're seeing my screen, I think. So yes, my name is Niklas and I'm representing DESME. We're a Danish pump manufacturer. And then we're talking about high efficiency pumps and to save energy and then saving money. So then how we'll do that. So what is an energy efficiency centrifugal pump? One energy efficient centrifugal pump characterized by the minimize of the energy losses in the pumps. And the features of that, it's we have then a good design, well designed in for the casing, impeller, and everything, bearing, seals. So the energy efficiency indicate how much energy is converted to power, usable power in relation to energy consumption. So that's about, yeah, we're talking about losses in the pump. And how do we get an energy efficient pump? We can start with a hydraulic design. We're talking about casing and things like that. To minimize the losses in the casing, we have some special casting for the pump casings, so the surface will be as smooth as possible, so the media can run through the pump much easier. We need to design the impeller and optimize that for the duty point, so we can have the best energy efficient duty point for your demands. And to using high quality bearing and mechanical seals, also important that we need to decrease the frictions for all rotating parts in the centrifugal pump. And use energy efficient motors. It's a must today. All motors and the new motors standards will be more and more better. And if this is not enough, we can special coat inside the motor and inside the casing and also the pump. Then we increase the efficiency about 3 to 5% more. We're talking about centrifugal pumps. The single suction is most common. But if we have higher flows, we always use double suction pumps. Then we increase the energy efficiency also. then we need to get the liquid from 2 ways in the impeller instead of 1 way. As mentioned before, the electric motors are important. When you purchase an electric motor, is the purchase about just 3%, and 97% is energy losses. So if you compare an for IE3 motor and IE4 motor, it's in the general losses about 20% difference between these 2 motor standards. And to these days we have also IE5 and the knock-in door to IE6 also, the markets. And when we run centrifugal pump, we always try to use VFD also. Why? Yes, if you don't have the frequency drives, you always run the pump at full speed, and you can just adjust the flow with valves. And the pump is just energy efficient in 1 duty point. So compare with that, when you're using frequency drives, you can have the whole full size impeller and work over the old range in the pump. Here's one example. This example to the left is without frequency drives, and to the right is with frequency drives. We have the flow 800 cubic meters and the pressure of 40 liquid meters columns. For the first, we can, if we run the pump with frequency drive, we have 1 smaller size with the pump. So from the start, we have save money for that. The impeller is smaller. We go a little bit higher in the speed in the pump to go to the correct duty point, best efficiency there. We use 101 kilowatts instead of 110 kilowatts for the duty point. Okay. And we're saving about 3% of the total energies in the losses in the pump. And then also we can add the pressure transmitter or flow meter, so we can measure that the pumps runs correctly in your systems. So then we don't need to run that on wrong duty points. So we can use the needs in the net from the customers. So why is energy efficient high energy efficient important? Operating cost, energy efficient pumps have reduced the power consumption. And we have the environment aspects also. We are saving at the environment. And a better designed pump have a longer lifetime. This is a little bit more general than Lars shows. So when we're looking for a pump for a lifetime of 15 to 20 years, the initial cost is about 10%. Then we have included the installation there also. The maintenance is about 5% of the total cost, and the energy cost is 85% of the total for the pump. And I will have one here. We have a study we have made in Ukraine to replacement pumps. The total of investment is for the pump is 527,000 euros. But to achieve the savings of energy is the payoff for this pump replacements just 2 years. Then the company just saving money to change this. And here in the graph is a little bit more, you can see it much more better. So the installation 25 and 27, it's plus minus null. Then you're saving money all the way. So that's me, our key competences for energy pump solutions. We always try to give you the most energy efficient pump for your demands. And we can help you also and give you suggestions to can do things another way if you have then you have things. So we always try to help you. So if we summarize this a little bit, to get the best solution for you, choose an energy efficient pump as possible. Optimize the duty point that, as Lars also, that's where you have the most of your running hours. Choose correct electric motors. We use VFD and use it for a pressure transmitter together. If you use this, it's a little bit higher initial cost maybe to invest in this, but you're saving a lot of energy and you're saving money. So thank you for me.
Thank you, Nicholas. Дякую попереднім спікерам. В нас залишилось ще 2 презентації, нагадую. Я в чат скинула новий лінк, і також Максим надав ще один лінк на Dropbox. Ви там також можете скачати презентації, кому як зручно. Так, і передаю слово нашому наступному спікеру, представник компанії Logstor. Поговоримо трішечки про мережу. Роберт Хетцел, регіональний директор. Роберт, будь ласка. We can see the screen. That's fine.
Hello, do you see the screen? Yes, hello. My name is Robert Hetzel. I'm from company Logstor or Kingspan Logstor. Before I will dive to the total cost of ownership, thank you to have a possibility to have a short presentation here. Thank you to Lars to have a nice entree to our presentation. We are the Danish company. I am a Czech citizen. We producing 80% of the pipes in Poland. And then I checked this morning that distance from Earth to Moon is 384,000 kilometers. And the Logstor produced 500,000 kilometers in 60 years. That very, 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 very quickly we will be able to deliver the pipes to Moon and back. Back to our business, back to our calculation. Lars had presented the possibility of free tool downloadable from our pages or used from our web pages, logstor.com. He mentioned the Logstor calculator. Now I am presenting the TCO calculation, which means total cost of ownership for the pipeline. You may easily do it by your own, but I will present you the offline result what I prepared for one of my customer in the Czech Republic. Simply, it is based on all the costs what's related to the ownership of the pipeline within 50 years of lifetime of the pipes. Simply, hopefully you see the details, you see the figures there. You simply choose your own conditions for your network. In this case, we have 120 degrees winter heating temperature, 60 degrees in summer. We have the 80 degrees centigrade winter return temperature and 40 summer. We have a temperature of soil calculated. We have a days of operation, 250 days in a year by the winter. We calculated the pressure, soil cover, and the lambda of soil. We have it now in euro currency. We may play with the interest rates. We have a 0 right now. Period for calculation is 50 years. Energy unit is the megawatt hours. We had the energy price 35 euro. And then we choose the fuel type natural gas. You may choose the different one. We made calculated in that case the 55 terajoule of CO2 per ton of CO2 per terajoule of heat. And we have a CO2 pricing, and the number of years in the TCO is a 50. For you, it is a simple task for all of you. Most simple is to send an email to me and I will do a calculation for you. But if you will want to make it on your own, you will simply enter the length meters of the pipeline here. That the first row means 3,760 meters of DN500. And all the other dimensions you will fill here. Then when you press the button calculate, then you have a possibility to calculate the result. Of course, it is a little bit adjustable that you may think that you have a pipe material complexity. It means it is the standard project. It is the standard share of the fittings and the straight pipes. If you will have the more fittings in city centers by connection the houses, you will put the slider to the right to the more complicated. If you do a trench excavation in the green field or in the city center, again, you may use the slider to be easy or complicated. Pipe installation the same, energy price the same. Then after the click, show me result, that you have the calculations. That I will firstly show the group of a DN65 till DN100. Second group is DN125 to DN200 for the medium. And next part is the DN2500 to DN500. And we do not have the bigger dimensions there. That I will show you the result for the biggest one. For the biggest one, DN250 to DN500. As the Lars said, you have the possibilities to choose what kind of insulation, what kind of pipe is best way for your project. I am in the business for some years, and I know that the most focus is placed always in the quotation for the price of the pipes. But if you see, the price of pipe is that very small blue part of a column. And if we will talk about the price of pipe, you see the size of the blue color, blue bar is very small and very similar. But you may have the result while using the typical pre-insulated pipes in the first class insulation. We may talk about the total cost for ownership for 50 years is the 129,200. Oh, it's a millions of euro, 129 million euro. And of course that you see what is the loss. That of course that you buy the cheapest pipe, but you pay the cheapest pipe for 50 years, the most expensive energy loss. Those bars represent the standard pipe in second class of insulation and the third class of insulation. You may see how drastically the energy loss can drop. If you will choose the Conti pipes without the diffusion barrier, the situation is very similar. But if you will choose the pair of pipes with the Conti line with diffusion barrier, that you have highlighted the best option. That you may see that's the difference in the price of the pipes is not that difficult, but you may reduce by 1/3, maybe maybe 40%. You may reduce your energy loss. If you want to have the other colors, that the blue is the pipe material, the gray is the trench excavation. That if we take the overview about the gray part is more costly than the pipe itself. The yellow part is the installation, And all this is much less than energy loss. That it's always advising you to think for the full output of the pipeline within 50 years. Then if we talk about the CO2 emissions, then we comparing the first class insulation we took as the reference point in the 50 years, that we producing 13 tons of CO2 emissions. And if you will choose the different second class, third class in insulation, diffusion barrier pipes, traditional twin pipes, and twin pipes with diffusion barrier, that you may see what impact we have by saving the CO2. I just talk about that this is the general issue about saving CO2 till 2030 or 2050 to be CO2 neutral, that it is for the ownership for the pipeline is very important. I don't want to be too detailed in the process in the presentation, but for you it's best to remember that to find the contact to Robert Hetzel from Logstar, then I will advise you how to use the free tool on our web pages, or I will do the calculation for your project. That's all from me. Thank you very much. Hopefully I'm in time, and I will stay for the future questions. Thank you very much.
Дякую, Роберт. Thank you. В нас є остання презентація. Я також нагадую, що можете скидувати вже трошку питання в чат, будемо їх відслідковувати. Останній спікер – це Педер Енкер Ларсен, представник і заступник директора Данського експортного фонду IFO. І він розповість нам про довгострокове фінансування від IFO, яке є також доступним із цікавим грантовим компонентом для підприємств центрального теплопостачання. Петр, будь ласка.
Thank you, Lesja. I think you made a presentation of me there, if I'm understanding right. Am I sharing my presentation with you guys now? Can you see it?
Yes, we can see it.
Super. Perfect. First of all, thank you, Lesja and Danish District Board of Heating, for inviting IFO this morning to do a presentation of our possibilities in Ukraine. As you rightly mentioned, Lesja, my name is Peter Larsen, and I'm working for IFO. My agenda today will be to give you a short description of IFO, and secondly, what we are doing in IFO, what would be our requirement to do financing in Ukraine. And of course, it's interesting for you to hear more about financing now. You have heard a lot of the possibilities you have within district heating and what Danish companies can offer you, and therefore we thought it would be appropriate also to give you some guidance of how these investments can be financed. And I will do that in the next 10 minutes because that was time allows for, but it will be sufficient. First of all, IFO is a Danish state-owned bank, and we are looking into exporting Danish companies when they are going abroad, when they're exporting their products to foreign countries. And therefore, it's also, of course, appropriate for you to hear what we can offer you in case you should buy products from Denmark or products. And as you can see, we are it's not the biggest bank, but then again, we are quite a size. We have 3,500 customers, and then our balance is 10 billion euros. What I would like to mention is also that IFO, when working in Ukraine, we are very much in favor of working with the. Was that a question or? Okay. I'll just continuing. We like to very much work together with Ukrainian banks, and today we are working together with Ukrexim or Shatbank and private bank, and therefore I would say the interest point to working with IFU might be one of those banks, which if you're looking into investments in district heating. You could start your talks with the banks, and these banks knows very well IFU. It could also be us, of course, but I would recommend that you also involve some of the bigger banks in Ukraine going through this. IFU, we have a Ukraine mandate to support. You could say to support Ukraine, and especially after the full-scale invasions by the Russians in 2022. The Danish government decided that they wanted to support Ukraine not only with military equipment, but also with, you could say, civilian products. And for that, that has been established a facility within IFU, which is total size is 755 million euros. A lot of that has been spent already, and that's good. Maybe some of you have heard about the Tyrigulske wind farm, which is a quite a sizable investment in Ukraine, and we have been proud, of course, to participate in that. But we have still funds available for projects in Ukraine. We see a huge demand for projects, and that's of course as a consequence of the war, but also a consequence of that the Ukrainian company and public sector wants to do investments in infrastructure. IFU works in two ways. We can either work as a normal bank that we are coming with a loan facility to a lender in Ukraine, but we also work as a guarantee provider for Ukrainian banks. So you could say the Ukrainian banks will lend money to the project of the public enterprise or the company, and then IFU is behind with a guarantee to the bank, basically meaning that if the bank is lending money and the Ukrainian bank is lending money out, they will have a risk on a Ukrainian buyer, and they can replace that risk, mitigate it, I would say, with a guarantee from IFU. We are covering both commercial and political risk cover, and basically that means that the bank is covered around if the client is not paying for commercial reasons, the business is going wrong, then they're not able to pay, then we will cover them, or for political reasons, as the case unfortunately right now in Ukraine, there's a war ongoing, and you never know how that will affect your business. We can guarantee up to 100%, and that's a special feature under our Ukraine facility. Normally, we never guarantees up to 100%, but in order to make it more attractive to go to Ukraine for Danish companies, we have decided that we want to support them with a 100% guarantee, basically meaning that the banks or the Danish exporters, if they are providing a credit, they don't have a risk themselves on the financing. It will all be covered by IFU. That's of course again due to the Danish government have decided that they want to support as much as possible Ukraine in under the present circumstances. We can give cover up to 15 years for district heating. So it means that, of course, that will smoothen out the investment for larger projects. There you are able to get a repayment debt up to 15 years. And I think that's good to know when you have to look into the cash flow calculations. For Ukraine, we have two programs. We're working with the public sector and with the private companies. And I would say the biggest difference between these two programs is that for projects in the public sector, there we are able to offer a grant of 40%, and that's quite a huge amount. But basically, that means that if you are to borrow 10 million euros, and we are to support the project, we decide that it's a project that we can support and we have funding, then you could receive up to 40% grant for the individual project, as we have spoken about earlier today. For private companies, I would say we work on normal basis, completely normal basis. We have decided to work full scale in Ukraine. So there's not a grant possibility, but we will provide loan and guarantees as we do in any other countries around the world. The only thing I would like to say is that our financing, both for public and private companies, is in the high end due to the high risk in Ukraine at the moment. On the other hand, I would also say that we think that we have seen that we actually are attractive for a lot of clients in Ukraine. Here on the map, you can see where we are active today. This map includes, you could say, our pipeline, but also our present portfolio. And what you could say here is that we are all over Ukraine. Of course, in the eastern part, not so active. That's primarily a credit risk issue, but we are there. And in the rest of Ukraine, we are also, you could see, engaged. So I would say that we are all over Ukraine. And today we have closed since 2022. We have closed 19 transactions, and under the Ukraine fund, we have deployed 40 million euros, and then under we have also deployed funds for the Danish government for 380 million. So in total, 420 million euros has been deployed by IFO in Ukraine. And you can see here, we are in many different sectors. So far, not in district heating, but as I understand, we will soon be involved in projects there. Being careful of the time, I just think you give you a short description of what would our requirements be for participating in projects today. I would like to highlight that we need to have a Danish content. Sorry, trying to find there. Yes, we would need to have 30% Danish content in the projects that we are financing. That's what that basically means is for IFO to participate in financing projects in Ukraine, there needs to be a Danish angle, a Danish economic interest in the project. Not 100%, but at least 30% of the project amount that we financed needs to be through investments via Danish companies. Then we have, you could say, we have received sources from the Danish government to spend in Ukraine, and therefore we are picky, or you could say we not finance everything in Ukraine because we have limited resources. So we are looking into what kind of projects we are financing. I would say so far we have not been that critical, but basically that means that we have a pre-screening committee that looks into all projects before we pass them on to our operations, or you can say credit analysis department. Then we like to work with borrowers that has been existing at least for the 5 last years in Ukraine. A rule of thumb is that the loan amount the share capital should be 3 times bigger than the loan amount. It's as a rule of thumb. It's not a hard measurement, but it's a good indication of what is your company or able to lend from IFO. Then I would say before you involve IFO, for us, it's a paramount amount that we can see that it's a mature project. And the reason for me saying this is that we have been approached by a lot of companies that are asking for, you could say, us to give a commitment to do financing. And we will not do that unless we can see there's a clear visibility of a Danish company being involved in the transaction and the amount size. And so we can, on that the size of the Danish contract, what will we be able to finance? Then we work as any other banks. Of course, finally, before we make our final decision, we would look at the credit risk for the project. How to work with IFO? That's as the first thing I would say. Find a Danish exporter or supplier of goods, and when you have gone to, you could say, find out that it's a supplier that you would like to work with, then you should submit our expression of interest to us. And being mindful of the time again, I would say that we have here on our homepage, you can find our expression of interest, and I know Alicia later on will forward you my presentation, and here there's a link up here. If you click on that, you will get to our dedicated homepage for our Ukraine facility, and here you would find the expression of interest. And again, I would say before you are going to this, it's a small scheme. You can see here, but just basic information, and that is needed for our screening committee to decide whether it's a project that is within the scope of the Ukraine facility, and it's a project that they believe IFO can work with. And if they decide based on this small application, then it will be passed on to our credit analysis team, and they will take your project further from there. Lesia, I could have done this longer, but I know that I'm supposed to have been finished 7 minutes ago, so I will stop now unless there's something specific questions here.
Thank you, Peter. I think that there should be a lot of questions from the audience, but I don't know if we have time for that. I will switch into Ukrainian. Колеги, шановні, будь ласка, якщо є питання, ми вже завершили всі презентації. Я бачу одне питання в чаті, і воно стосується бойлерів. Дмитро, чи, будь ласка, перекладіть його також. Доброго дня. Підкажіть, скільки на 1 тонну гранул при спалюванні бойлером утворюється відходів? Дякую. Питання від Олексія Десни. Це питання до Єспера. Єспер, чи ви з нами? Так, не бачу Єспера. Але ми спробуємо це вирішити, можливо, в індивідуальному порядку, вже пізніше тоді. Інші питання, будь ласка. Можливо, до IFO, можливо, до інших спікерів. Так, не бачу питань. Але, можливо, тоді додам від себе ще раз, чи можна замовити feasibility? Так, я зараз розкажу трошечки про feasibility і про проекти, які ми робимо. Буквально 2 слова. Наразі DBDH працює в Україні по 2 напрямках. Перший, багато з вас хто знає, це організація стадітурів в Данію. В минулому році ми зібрали делегацію, поїхали представники, мені здається, 9 міст, тобто компанії з теплопостачання, представники міської ради. І в цьому році також була делегація, тому я і кажу, що дуже радію з того, що багато колег доєдналися, кого я знаю особисто. Ми від DBDH, звичайно, зацікавлені в тому, щоб ми нарощували цю співпрацю, щоб ми знайомилися особисто із кожним із вас, щоб розуміли, що відбувається в містах, в системах теплопостачання. І другий напрямок, який ми реалізуємо, це IFO Green Accelerator. Це програма, яка фінансується за допомогою IFO, який фонд представляє наразі Педер Ларсен на цьому вебінарі. Але це окрема програма, і в рамках якої можна профінансувати будь-які підготовчі роботи, які ведуть до модернізації систем теплопостачання. І наразі ми закінчуємо проєкт в місті Рівному. Я дуже рада бачити тут колег з Рівного. Ми дуже щільно співпрацювали на протязі року, і компанією Рамболь була розроблена технічна оцінка систем модернізації саме із фокусом на насосну групу, на тепломережі та на встановлення теплогенерації на біомасових котлах. Ми також в рамках цього проєкту ми будуємо діалог із фінансовими інституціями і допомагаємо залучити фінансування. І наразі от якраз є вже діалог із IFO, між Рівнем і IFO, для того, щоб, можливо, податися на таке фінансування, його отримати і розпочати цю модернізацію. Тобто в нас є функціонал в DBDH, ми на ці проєкти також подаємось, їх небагато, тому що ми працюємо, і особисто я працюю і по інших ринках, і Польща, і Молдова, ну, тобто це Східна Європа. Тому ми дуже обмежені в ресурсах, але якісь зусилля ми можемо об'єднати, і щось ми можемо поставити на планування, і до мене там звертаються нові міста, нові компанії. Я наразі скину свої контакти в цей чат, і якщо, звичайно, є ідеї або запити, якісь конкретні, будь ласка, пишіть. Український номер також є, це на месенджерах, тому я буду рада продовжити діалог. Так, контакти скинула. Чи є інші питання? Цей вебінар було записано. Максим, так, ми матимемо записи. Якщо комусь буде цікаво, будь ласка, звертайтесь. Ми надамо запис, якщо ви хочете поділитися знаннями з колегами. Я думаю, що це перший вебінар, який робить DBDH за часів війни. І сподіваюсь, ми знову вийдемо з вами на зв'язок із наступними ідеями. І, звичайно, я буду рада почути, якщо у вас є ідеї, які теми вам хотілося б почути більше або розкрити. Ми можемо робити такі більш фокусні, закриті вебінари на конкретні теми по технологіях. Ще раз дякую. Питань не бачу, тому ще раз хочу подякувати нашим партнерам проєкту «Угода мерів Схід» і Оксані Кисиль, і Максиму Верещуку, і також колегам. І так, побажати вам стійкості в ці складні часи і сказати ще раз, що ви всі неймовірні. Також подякувати спікерам. Дякую. Всім тихого дня.
Дякуємо вам, Леся. Всім до побачення.
До побачення.
Thank you. Bye bye.